This 3-ton FAB-3000 is a Cold War-era demolition bomb, currently seeing massive deployment 70 years after its design was first standardized. Mid-century bombing sites were notorious for poor accuracy. To ensure a target was destroyed from high altitude, mission planners compensated for high margins of error with raw explosive yield. It was built to obliterate naval bases, deep command bunkers, and heavy industrial facilities through sheer, blunt force overpressure. Even a non-direct hit within the targeting area could cause catastrophic structural failure. These engineering choices created a highly effective bunker buster for the 1950s. However, the modern battlefield presents a delivery problem. A slow, unguided gravity bomb is extremely vulnerable to 21st century air defenses. In the airspace over Ukraine, dropping a traditional freefall bomb requires a jet to fly directly over the target. For a pilot, flying into the teeth of modern surface-to-air missile networks is a tactical suicide mission. Russia can use tactical cruise missiles like the Caliber for safe standoff strikes, but the economics are lopsided. Each missile costs over $1 million and carries only 500 kilograms of explosives, making it far too expensive for mass, daily bombardment. Economic constraints drove a radical solution. By digging into their depreciated Cold War stockpiles, the Russian military found a way to transform their largest unguided dumb bombs into a modern standoff weapon. Released at high altitude, the bomb separates from the pylon, rolls 180 degrees, and a pyrotechnic charge deploys its spring-loaded wings. This mechanical retrofit transforms a vertical drop into an active glide, extending the maximum standoff range to an estimated 50 to 60 kilometers. While officially claimed to have a 10-meter margin of error, active electronic warfare frequently degrades the satellite signal. In combat conditions, the bomb must often rely on its backup inertial navigation, resulting in a practical accuracy of 30 to 50 meters. That lack of pinpoint accuracy is mitigated by the sheer physics of the blast. An error margin of 50 meters is effectively negated when the weapon generates a continuous destruction radius of 230 meters. The secondary effects cover even more ground. Personnel within 24 meters face a 100% probability of kill, while metallic fragments from the shattered steel body retain lethal kinetic energy at distances exceeding 1,200 meters from the epicenter. Along the Kharkiv front, Russia is now launching roughly 3,500 glide bombs per month to erase Ukrainian defensive positions. This volume of heavy explosives allows Russian ground forces to advance by systematically vaporizing the buildings and structures that anchor the front line. Ground-based air defenses struggle to stop the UMPK. The gliders have a tiny radar cross-section, no heat-emitting engine to track, and a very short flight time from detection to impact. The only reliable countermeasure is to kill the Archer rather than the Arrow. Ukraine must ambush the carrier aircraft before they can reach the altitude and distance required to release their payload. To achieve this, Ukraine is relying on newly pledged Western technology, including Patriot missile batteries and F-16 fighter jets, to push Russian strike bombers further back from the front. The integration of the UMPK kit into legacy 3-ton munitions demonstrates a shift toward high-volume, cost-effective bombardment. By scaling up 1950s designs, the Russian military can bypass expensive production lines while sustaining pressure on fortified defensive networks.